Last one of this review sheet is going to have a simultaneous equation in it, so I'm greatly looking forward to this. We'll start with the normal things. We're saying x is a normal distribution, and we've got a mean of mu and a variance of sigma squared, so the standard deviation sigma. Let's take the information. The sample is 10% are longer than 3.68. So the probability that x is bigger than 3.68 is 10% or 0.1. Let me just draw a picture for that so I can understand it again. Bigger than it is just 10%. So lower than that must be 0.9 or 90%. So if I look up the 0.9 value, if I look up the value of 0.9, I get this 1.2816. And that is the value for 3.86, take away the mean, and divided by the standard deviation. And that's my first equation for my simultaneous that I'm going to work on. 3.86, take away the mean, is equal to 1.28 times by sigma. Let's park that there for a minute. We'll come back to it in a second. Now let's interpret the second part of it. 3% are shorter than this much. So the probability that x is lower than 3.52 is just 3%, 0.03. Right, tiny. 3%, just 3% down here are shorter than that value there. So what have you got there? You've got 97% of it up here. So there's 97%. So flip it round and look up the 0.97 value, and that gives you the 1.88 value. And so the value we want is the minus 1.88. So what have you got here? You've got 3.52 minus mu over sigma is now equal to minus 1.88, because that's the value we got there. Let's have this as our second equation then. 3.52 minus mu equals minus 1.88 sigma. There's my two equations. And I think we just look at those now. With all the stats is done, we could, should we cite, right, same sign, so we're going to subtract the two of them. One take away the other. That take away, that gives me 0.16. Mu minus mu cancels out, that's why we did it. And 1.28 minus 1. All right, we've got a plus there, haven't we? 3.16 sigma. Finally, dividing both sides by the 3.16, that gives me a tiny value, 0.0506329. And did it ask for that? It actually asked for the variance. The variance, so if I square that, sigma squared, if I square that times it by itself, what's that again? 0.02, oh, I got it right, 0.0256. That's good. What else have we got to do? We've got to find out what the mean is as well. Well, that's okay now. We're just going to throw this thing here. So we're just going to throw this sigma in here back into either one of these two things, and that will then show us what the mean is as well. You can do